Okay, so this problem is about particle motion. A particle is moving along the x-axis in such a way that its position at time t is given by x of t equals 1 minus t over 1 plus t. What is the acceleration of the particle at time t equals 0? So the first important thing is you need to know the relationship between position and acceleration. So position, when you take its derivative, you get velocity is the first derivative of position. And then the first derivative of velocity is acceleration, which would be the second derivative of position. So that's going to be our first goal, is to figure out what the second derivative of position will be. So we are starting with the position function x of t equals 1 minus t over 1 plus t. So for this first part, when I do the first derivative here, I'm going to use the quotient rule. And if you remember the quotient rule, if you are doing the derivative of f of x over g of x, the derivative will be, let's say this is going to be y equals, y prime would be g of x times f prime of x, so times, minus f of x times g prime of x, all over g of x squared. Sometimes I say that the easy way to remember this is to do low d high minus high d low over low squared. So low times the derivative of the high function minus the high function times the derivative of the lower function, all over the lower function squared. Whichever way you want to remember that will work. So for this one, we are doing the lower function, which is g of x, which is 1 plus t times the derivative of the upper function, which is negative 1, minus the upper function times the derivative of the lower function, which is 1, all over the lower function squared. So I'm going to go ahead and distribute, and we have that x prime of t, or v of t, if you want to call it velocity, we could do that, is negative 1 minus t, so I'm distributing the negative sign here. I'm also going to distribute this negative sign, so minus 1 plus t all over 1 plus t squared. So simplifying this, you end up with negative 2 over 1 plus t squared, and that is the function for velocity, or for the first derivative of position. So we now need to find the derivative of velocity, which, to do that, I would rewrite the velocity function as negative 2 times 1 plus t to the negative 2. So for this problem, now what we're going to do is use the chain rule. So we're going to cover up the inside. So basically we're going to ignore the stuff inside the parentheses, and we're going to do the power rule. We bring down the negative 2. So negative 2 times negative 2 is positive 4. We leave the inside function alone. And then to the negative 3, we subtract 1 from here. And then times the derivative of the inside, which happens to be 1. So kind of rewriting this, we get 4 over 1 plus t cubed. Remember, negative exponents go back in the denominator. So this actually is v prime, or if you want to call it, acceleration. And our last step is to be able to figure out what is acceleration at t equals 0. So we get 4 over, and now we're actually plugging 0 in. So we're getting 4 over 1 cubed, which is just 4, which on your paper was answer choice E.